All right, folks, Mr. Buckle here with example 1 from our lesson on 4.3, which is solving systems of equations with elimination. And elimination is a way to solve a system of equations. A system of equations is two equations where we have two variables in this case, could be more. And we're going to find out what x and y are in both of these equations to make both of these equations true. So x and y could be any numbers. We want to figure out exactly what numbers they are, so that both of these equations are true when we plug in the numbers x and y. And we're going to use elimination here. And elimination is nice to use in this case because both of these equations here are in the same form. They're both in standard form. We have the x plus the y equals a number. And in the bottom equation, we have 2x plus or minus a y equals a number. So both of these are in standard form. They're both nicely laid out, so we can add these equations together, which sounds like a weird thing, and we're going to add them together in an effort to eliminate one of the variables, and one of the variables will be eliminated in this case. In this case, it's going to be y, and we will have just x, and then we can solve for x and then go find out what y is. So it might sound confusing, so let's do this and then see kind of what happens, and it might make a little bit more sense. So I have both these equations, our x terms are lined up, our y terms are lined up, our equal signs are lined up, and then we have these constants lined up. They're in the same form, standard form. I'm going to add these equations together. 1x, it's a positive x, plus a positive 2x is 3x. And then I have a positive y plus a negative y, which will be 0. Our equal signs will come right down, and then 7 plus 2 will be 9. So when I add these equations together, I get 3x, because x plus 2x is 3x. Notice there's no y term in here because those y's canceled out. Positive y, negative y is 0, so there's no y there at all. It's gone. It's been eliminated. Equal sign lines up, and then this 9 comes from 7 plus 2. So when I add these equations together, I get 3x equals 9, and if 3x equals 9, divide both sides by 3, therefore x has to be 3. Now I know x is 3 in these two equations, so what I can do now is take this 3, plug it in for x, into either one of these two equations, because this x is the same as that x, and that x is 3. We found that out by eliminating the y's. So I'm going to take the top equation, because it looks a little bit nicer, and this top equation now is going to become 3 plus y equals 7. The 3, replace the x, because the x is 3. And if 3 plus y equals 7, what I can do is subtract 3 on both sides, and get y equals 4. So the solution to this system is x is 3 and y is 4, and we can plug that in and check. So now what I've done right here is I've taken the bottom equation. I can take either one. I'm going to take this bottom equation and I'm going to replace this x with 3 because x is 3. I'm going to replace that y with 4 because y is 4, and see if this works, and it should, because that's the solution that I got. So I have 2 times 3 minus 4 equals 2. 2 times 3 is 6. 6 minus 4 equals 2, and 6 minus 4 is 2. 2 equals 2. That checks out. So our solution to this system is x is 3 and y is 4.